Hi students, welcome to this course, PLC Automation and Introduction to Programmable Logic Controller. I am Professor Yao. Large process ladder diagrams construction. The keywords: a large process, carry out, operational check-in, adjustments, go astray, fundamental. Some of these steps in planning a program for a large process are: number one, define the process to be controlled. Number two, make a sketch of the process operation. Number three, create a written step sequence listing for the process. Number four, add sensors on the sketch as needed to carry out the control sequence. Edit manual controls as needed for process setup or operational check-in. Number six, consider the safety of the operating personnel and make additions and adjustments as needed. Number seven, add master stop switches as required for safe shutdown. Number eight, create the ladder logic diagram that will be used as the basis for the PLC program. Number nine, consider the what if, where the process sequence may go astray. To illustrate the 9 steps of the planning sequence, we use a fundamental industrial control problem. We then go through the creative process to illustrate each of the steps of the planning process. Step number one, define the problems. The keywords: spray painting, a mandrel, pneumatic actuator, a pneumatic cylinder, piston. We wish to set up a system for spray painting parts. A part is to be placed on a mandrel. When the part is in place, two push buttons are placed and then the mandrel rises. After the part rises to the top and it is in the hood, it is to have spray paint applied for a period of 6 seconds. At the end of the 6 seconds, the mandrel returns to the original position. The painted part is then removed from the mandrel by hand. Perhaps a word or two on pneumatic power would be in order before we proceed, since we will be employing a pneumatic cylinder in our spray process system. With the linear pneumatic actuator of the type used here, an electrically activated air valve allows air in to press against a pneumatic cylinder, forcing the latter upward. When the valve is open, down comes the cylinder, the result of gravity and the downward spring action. In more complicated pneumatic system, a four-way spool valve is used to permit air to be forced to either side of a cylinder or piston. Thus, both forward and backward motion is accurately controlled. Such pneumatic systems are employed extensively in robot control. Step number 2, make a sketch of the process. This picture shows the sketch of the spray process system. The spray paint hood, the mandrel, part placed here, part raises into hood, the paint valve, the paint reservoir and pump, start and stop button, pneumatic valve to rise part by pneumatic cylinder, spring returns down when off. Step number 3, list the sequence of operational steps. The keywords: painting pump, spring, pneumatic air supply, valve, rising mandrel. The following is a step sequence for this process. Turn on the paint pump and the pneumatic air supply. Turn on the system on. This requires push buttons other than the system buttons. Put the part on the mandrel. A sensor indicates that the part is in place. Push the master start button and the two system start buttons. Having to push two system start buttons with both hands reduce the possibility of the operator's hand being injured by the rising mandrel. The mandrel is raised by a pneumatic cylinder energized by the opening of an electrical actuated air valve. When the system start buttons are placed, the mandrel will return by gravity and a downward spring action. When the valve is reopened, when the mandrel rises, the part in place sensor at the bottom becomes de-energized. When the part reaches the top and is under the hood, it is held against a stop by air pressure. A sensor has indicated that the part has reached the top. A timer starts and runs for 6 seconds. During the timing period, 6 seconds, paint is applied by the sprayer. At the end of 6 seconds, painting stops and the mandrel with the part on it lowers. The upper sensor is de-energized when the mandrel with the part on it descends. The part arrives at the bottom, re-energizing the part in place sensor. The part is removed from the mandrel. the system resets so that we may start at step 3 again. Homework. Handwriting all keywords and submitting them to Coach Facebook. Just do the online quiz. And see you next time.